Good morning, students. I hope you all are doing fine. So, in today's class, we'll learn about uh, shafts, keys, as well as about your springs. What are the types of spring? So, let's get started. Now, for shaft, we have to understand there are how many types. There are near about 5 types of shafts. One is axial shafts. That is what there is an example of axial shaft. What these shafts can be seen over your train. It is used in trains for transmitting from wheel transmission from this to this. So you could find over in wheel train wheel. Spindle, this is nothing but in Bengali, in Hindi it is told as chakri. So what we do is we just spin this one and it rotates. Next we have counter shaft, that means shaft upon shaft upon shaft. That means there will be there may be a series of shaft inside it. That means there may be concentric shafts also. Concentric shaft means one hollow cylinder upon inside another hollow cylinder inside another hollow cylinder. So this can be also be done. That depends on the situation. Now this is a jacketed shaft where two shafts are made with couples. They meet with couple systems. Okay, the two shafts are make two work. So this is called jack shaft. And line shaft is a shaft, as you can see, a shaft where a number of pulleys are there. So this will rotate and this will make a rotation of other components, and the components will receive motions from the pulleys attached to the shaft. So there will be a big shaft, a long shaft with number of pulleys. Now how it is calculations are done is on the strength basis. How? The strength basis calculation is in terms of Mohs circle, where, as we know, that if it's in a negative side, it will be we consider as negative. If it's in compressive, it will be negative, and if it's positive, it will be. If it's tensile, then it will be positive. As per Mohs circle considerations, or by force, biaxial force determination. Fine. Then what are the basic formula governing? It's, we know, sigma t is equals to 4 p pi d square. So since we are dealing with the shaft, so what is the cross section of the shaft? It will be pi by 4. It will be what will be the cross section of the shaft? Is circle. So what will be that? Pi r square. So what is pi r? R is equals to d by 2. So what we can do? We can write pi d by 2 whole square, that is pi d square by 4, and the 4 being in the downside, it will come in the upwards, because sigma t is equals to force by area. So the force was used to be in the down, but due to the flipping of the sides, it comes on the 4. Now let us understand how it happens. For a simple way, sigma is equals to force by area. The cross section is equals to pi r square is equals to d square by 2 square. That is, it will be 4. So what happens? Now try to understand. It will be p d square into pi by 4. What happens? This 4 get over here. This is what happened. Fine. Let us clean this one. Thereafter, we have to understand what is left behind. So this is what it's a one governing, that is it for the tensile strengths. Now next is for the bending stress. We know sigma is equals to mby by I. So after this is for the governing, for the bending stress, and this is for the shear stress calculated. So as you can see over here. Now Now, as you know that sigma x, that is over here, if you consider this as x and y, sigma x is equals to sigma t plus b. It is considered as sigma t and sigma b. Sigma t is tensile and sigma b is bending. Next, sigma tau max, we know as per the principal stress strain theory, we have studied in the biaxial stress in the strength of materials. From there we can find out. We'll substitute over here and we'll try to obtain this one. How? Now this comes in this way, that sigma 1, as we know, how to calculate the sigma 1 this to this. What happens? There is the torque generated because a shaft. Try to understand what happens when a shaft is rotating. Shaft, let me find out. So when a shaft is rotated, the shaft looks like this. When a shaft rotates, it creates some type of torque. Okay, so this torque is calculated like here you can see this is the torque, and mb, we know mb is for the bending. Okay, as you can see this is the bending, due to bending, that is, what is this? This is nothing but your moment. Okay, moment due to the force induction on the shaft, how much force is applied. For example, to make it understand in a simple way, since you can see this train, what happens when it rotates, it keeps force is acting on over here. That means this shaft is induced under certain force. As well as if you see over here, this pulley is under a force towards this side, and this pulley is force under this side. What happens? This line shaft experiences a force of this way and experiences a force in this way. Fine. Okay, next. So we came to know about it. So this is what we have substituted sigma 1, and we find out this one. So after complete substitution and everything, we could deduce in this manner. So what happens? This gives us strength, biasness of what happens, and this is what we can design a shaft. We can design, for designing a shaft, we should maintain these things. What? Sigma 1 to calculate this principal stress strain, as you can see over here. See, tau max is equals to sigma b 16 pi d cube root over mb square plus mt square. So this is clear about strength basis. And next we have to learn that if is a torsional rigidity. Torsion means a twisting action for which shaft can rip off. So what happens if a shaft gets torsion? If you consider this as a fixed point, this as a fixed point, this part as a fixed point, okay, and you give a torque over here, there will be a small cringe point. What happens? That a torsion due to torsional action, this can go on. So this is how it works actually. So what happened? Theta is equals to, we know, 584 mtl by gd4. Well, from where we have considered, this was considered from your last torsion chapter in strength of materials. If you have any doubt, you may ask me. So what is ASME protocol for shaft design? ASME protocol says that you have to introduce two things, that is KB and KT. One is KB is the factor or a multiplier which will help to simulate or help to connect the practical body with theoretical things. That means the formulas what you have learned over here, that means from here, as you can see, this is all are theoretical, but for practical view you have to consider, you have to multiply a multiplier KB and KT. KT is as I have told you, KT is also a shock, but it's due to fatigue of torsional moment, and KB is for the bending moment. Okay, that means KB talks about if shaft is getting failure due to the bending, and shaft when get failure due to torsion, you have to give KT. That means KB and KT is a factor, mathematical factor, which has been derived after a number of calculations and number of experimentations. So who is ASME? First of all, ASME is American Society of Mechanical Engineers, who makes the protocols and the directives for the mechanical parts and particles in the entire world. Most of the countries maintain the ASME standards because these are the highest standards you can find in the entire world. Even our national standards are not even up to the mark to ASME. ASME is the most precise and highest standards. ASME and BIS. BIS is from the British International Standards. So what happens is what will be the kV value and kT value. To calculate the kV value, you can see if a load is applied gradually, that means a load applied on shaft is gradually, then kV value will be 1.5 and kT value will be 1.0. So this is how it works. For minor, that is for medium or something, this will be 1.5, in between 1.5 and 2.0, and that will be 1.0 and 1.5. Okay, 2.0. So this is your conversion. For sudden heavy, that means a sudden work is done, maximum power, it will be 2.0 and 3.0 and 1.5, 3.0. So that depends on how the loading on the shaft is done. Now there is a shaft problem. Let me give you a small interface. I'll teach you on the for this problem you need to have complete one class, because this shaft problem is understanding how it works and how it's not. So it took near about 1 hour to understand, but to solve it you need only 10 minutes maximum to maximum time. But today I'll not go for the shaft problem, but what you need to do, you have to keep me remember, you have to keep me ask me about this one shaft problem. I'll do in a later class. Okay, shaft problem for which we will find tau permissible stress. Then after torsional moment is calculated, this is what the thing. That's why I am coming. This is done due to this P1 by P2 is equals to E mu theta, because it's a belt right now. What this problem? A shaft, a transmission shaft. This is bearing and this is bearing. Two pulleys are over there. So this is the driver pulley and this is the driven pulley. This driver pulley has a belt that is wrapped, as you can see, that is wrapped vertically. Okay, and the small pulley is wrapped in horizontal way. So what happened? So this rotates, as well as this small pulley also rotates. What happened? The torque on this things is assumed to be same as this pulley also, as well as the weight of the pulley is considered as nil. So practically it's not possible, but theoretically we are calculating for now. So what happens, we for this belt tension, that is a belt tension, as you will see, so we can derive a formula, that is P1 by P2 is equal to E mu theta. So mu is the belt traction between the pulley and the between the belt and the pulley surface, the traction friction between the pulley and the belt, and theta is the angle at which it is wrapped. Now here you can see it is wrapped at 180, as you can see this is wrapped at 180. In some cases it is wrapped near about 330. Yes, correct, this cross belt, it is termed as cross belt. So even it can be 10 degree also. So it depends on how the arrangement of belt is done. So the formula remains same. How the formula remains, and theta is considered to be in radian. So what is the formula? This formula is this one, is derived from, so two pulleys are over there, an angle is subtended, so there is a force F2 and there is a force F1. So the formula can be F1 by F2 is equals to mu theta. The same concept I have given over here. Right? You have to do, because the force P1 is given over here, 2.5 kilonewton, and the SYT also is given, as you can see this is 400. After that what we do, we calculate P2. So we calculate the maximum P1 plus P2, and after that, as well as we calculate P3 plus P4. Since it is having a belt traction, even this P3 and P4 will also have. After so we'll get this one. As well as we know P3 and P4 will have same torque as if of this one, P1 and P2. So after we have calculated, as you can see, MT is equals to, we have calculated the torque. So we have substituted this torque over here and we have find it out on equation A and B. After comparing equation A and B, we have find P3 and P4. So MB at B, MB at C. So these are the points B and C. How much is the torque created and how to calculate. This is some line diagram. That's why I told you this is some line diagrams, simple line diagrams which will carry near about your 17.5 marks. This sum will carry 17.5 marks. Let be sure 17.5 marks. So here you will be able to calculate this very simple thing. I'll come to this sections and I'll do for you. I have just shown you a brief how to do the sums. We will do the sums. So after calculating a bending moment, so it is a resultant of bending moment. This is not a bending moment. This is a resultant of bending moments, and we go for tau max as we have learned in the previous class. What is tau max is 66.7. So after that we find out that D is equals to this one. It's simple, but there are some few things what you need to know about. How did we find 5882 and 294 as well as 1478? So you have to draw a diagram and you have to simply find out it. So I'll give you in the coming classes. Now to hold the shafts, that means to fix the shafts with the pulley or some, you can see, to hold every pulley and gears in the shaft or this wheel, you need to have a key. A key is someone irregular surface which actually hold. So why it is irregular? It is somewhat like it can be a square in shape, it can be a rectangular in shape, so it can be a cuboidal or it can be a tetrahedral. So it depends on how much. So basically it is a cuboidal. So there are basic key of saddle, sunk, squares, flat, taper, parallel, key, give head, keep, give. So many options there. So let us see some of the equations. Saddle is somewhere we give these things. This will be round shape and we will be putting inside the shaft and the pulley. And what happens there? The pulley is having a bit cut or straight cut. That's why this is kept straight and this one get inserted. Now what about the sunk? Sunk is having it can be the cross section seems like this only. Okay, this is the same thing itself. Now what is give head? Give head is having this is having no point to break it. I mean, in other words, there is no point to stop it. If you put on hammering on this pin, it will get inside. But what happens to a give head? Give head is having an extra material which restrict it from going beyond a certain limit, as you can see of this. Fine. What is feather keys? Feather keys is where we give small like this half cylindrical things what we put inside it, and this connects with this pulley and the shaft. Fine. Next, what is square and flat? Square and flat is the same like this one only. This one is square indent inside the half square indent, and the other half square indent is on the pulley. The same thing. There is nothing but there is the same although the things. And feather keys are there is a small key which is shaped on this one, and it is stepped over inside this one and with the pulley, so that connects with pulley and the shaft. The concept is same, just a bit difference. Same either is a half circle or that there is a one extra material is added. So the concept is same and there is some more difference at that. So what is coupling? Coupling. So this is what about keys, and what are couplings? Couplings is are a system or an object which connects two shafts. If there is a long shaft, you can't connect. You can't make a shaft of 10 meter continuously or 30 meter continuously, because the shaft will have a tendency to bend due to its self weight. As you have studied in strength of materials, as well as you know also that if a body is having a maximum weight or the length is maximum, so what happens? It tries to go. It is having like, I'll show you. Let me take a pen. Okay, if a shaft is a long shaft, for example 10 meter shaft, what happens? Due to the weight, it gets over here. It can go like this after a period of time. As well as when the shaft rotates, it vibrates to this one. Fine. So this is called, for restricting it, what we do, we break in parts, and we put we connect this two shafts with the help of coupling. We connect this two with the coupling, as well as we hold it with a device called plumber block. Okay, this is what happens in practical. I'm not talking about the simple thing. This is what happens in practical. So how does coupling looks like is something like as I have shown you, as you can see over here. Okay, as you can see over here. Fine. So what happens, there may be number of couplings. A screw will be by which will be clamped, that is for coupling for muff, and this is a clamp where number of supporting, as I have shown you right now. This can be there, also as well as it can be like this, with the help of two plates it will be connected, and plate will be connected with the shaft in terms of this your keys, as you can see over here, this keys. Okay, as you can see, this is a key. So there may be a lot of things what can be done. As well, you can see the boost pin key. So there there's a key attached with this one, and this is a plate, and this is a plate which connects with each other. So this is for coupling, and now we have learned about these things, about what is coupling, what is key. Now what is extra is the helical spring and how it works. Let us go for the helical spring. Now there are a lot of springs in the market. One is helical spring and one is leaf spring, but the difference is the spring mechanism used, as well as the spring design is changed, altered in times to time, but the basic spring, maintaining the basic spring design. For example, this is your helical spring, as you can see, find out in your ball pens also, in a tip ball pen, as well as this is a leaf spring which you can find under the undercarriage of a car or a wheel. Okay, so these two are a type of spring, two types of spring. So what happens, a spring has a length. Try to understand, a spring has a free length. That means a spring, when it is not compressed, has a free length, and when it is compressed, it's in a compressed length, and the solid length where it can't be more compressed. That means a maximum compressible length is termed as solid length. Now try to understand, when a compressed force is released, a deflection is created, that is del, or it is termed as x also in some, where a force P is applied. Now what happens, due to this one, I could write one things. Try to understand in this way. Let me take one screen, white screen. Okay, if a spring is there, let us draw a spring. Okay, spring, so spring, you are applying a force of P. Fine. If there is a deflection x, or change in dimensions, as you can see, as you have seen, that the compressed length, when it is released, it is a del given over here. So in some book it is also given as del. So some book it is also given as del. So it depends on what you consider. Fine. So how to understand what happens, so what happens is, you could write one formula, because the maximum force you will give, the maximum these things will occur. So what does it mean, that P is directly proportional to x, or P is equals to K into x. Sometimes it is replaced by F. F is equals to kx. Okay, kx. What is k? K is the spring index. Try to remember, K is the spring index. Okay, now let us let us go back to our thing where we could understand. See, this is what your the deflection is. Fine. The deflection is, and how it looks, how it you can see that del force is applied, P is equals to del x. Fine. Now you can see. Fine. The spring can be arranged in two ways, that is in a series way or in a parallel way. What happens if a series way spring is done? So if you are arranging a spring in a series way, the amount of force is P. So what happens, the force when PP is applied, the deflection will be in total, that means del 1 del 2. So total deflection will be del x equals to del is equals to del 1 plus del 2, as you can see, del 1 plus del 2, or you can write x is equals to x1 plus x2. What else you want to write? So as we know, P is equals to k into del, or P is equals to k into x. So what happens, as we know, so we'll be substituting del 1 is equals to P1 k1, P2 k2, and we know del is equals to P by k. So after putting this one, I know that the force over here are same. Okay, so I could remember, I could eliminate it, and I could write 1 by k is equals to this one. That means for springs to be in series, I could write this formulation. That means just like a capacitor. Fine. Capacitor in spring is having this capacitor in series works like this, the reciprocal form, and capacitor in parallel works in a simple addition process like over here. So what happened, P1 P force is applied. So what is happening, the force get divided in this one, P1 and P2. Fine. So what is the total force? P is equals to P1 plus P2. So what will be, P is equals to k del, so P1 is to k del, k1 del. So because the deflection will be same, as it is aligned in a same in a same way or in a parallel way. Okay. So what happens is P2 is equals to k2 del. So what happens, k is equals to, so after substituting this entire values, and I can find k is equals to k1 plus k2 k2 plus k3, so on. Style of ends, there may be, this may end up like this, that means half cut it, or this may be a plain cut, and as well as it may be a square end also. Okay, so this and this are now and then same only. It's a bit the end changes something, what happens. So square and ground end, which happens ground. So this is what plain end is empty. Plane and ground is number of turns, that means a turn, this turns, we are talking about turns, it's empty. This the number of turns, 1 2 3 1 2 3 4 5 6, and this 2 are 7, so NT will be 7, and this is half cutted, half is did, so NT minus half. So this is what happens for the square, it minus 2, because a square, you can see a complete thing is cutted and a complete thing is cutted, but these two are now and then same itself. Here when it is half grounded, it is square because it have been cutted over here. As well as for the ground one, there is a 1 and 1 half is cutted, reduced, therefore 2 is 2 turns are cutted, is eliminated. That's why we like to write NT minus 2. What are deflections of stress and deflection? How to calculate? Again, the same concept like in shaft. Torque tau will be considered, that is a shear in terms of shear in terms of torque. So we know, we have studied in the previous class, we know that tau is equals to this one. In torsional shear, we have calculated in the strength of materials. So from here we can write 8PD by pi d. So from here we can know this. As well as there will be one more thing, that Ks and Kc. Ks is a direct shear stress, and Kc is a stress concentration due to curvature stress. Now try to understand, these two factors are employed because to understand the practical scenario. Fine, how the practical scenario works, and how do it is work, how to get in the way. Okay. So this is a multiplier. This will be multiplied over here, as you will be seeing in the coming session. Now what is this? It's a spring. This is a spring diameter, spring wear diameter D, and this is the this capital D, caps D is the complete spring diameter. Fine. A force is applying over here. So what happens? A force is applying and D, and this is D by 2, D by 2. Okay. So we have to understand in this way. Now we know T1 is this one. So what will be T2? Again T2 we know shear is equals to P by force, shear is equals to force by area. What is the force? P, as is given. What will be area? This cross section, pi by 4 into D square. So after we know that we got this one, so what happens? We are substituting, we are playing a game of substitution over here. So what happens is, after making this one, what I do, we multiply this with 2. Okay, this makes 2 divided by 2. Okay, and we multiply here with D, and we multiply down with D, so we get this formulation. Try to understand. Multiply by 2, divide by 2, that's why it's 0.5, and multiply by into with a small d, that gives us d cube, and multiply with d at the numerator, that's why d, and we have a capital D on the numerator and denominator, which will bring back to this equation. So we are rearranging the equations with extra more things. So what do you know? That T1 is equals to T2 plus T3. Why we are doing this? To make these things and these things equal. That means this equation to look like as if of these equations. We are trying to make this way. That's why it's a shortcut process. So what happens with, after taking the common, we can do 1 plus 0.5 d in by d, that is small d by capital D. So tau is equals to, this one is equals to k is equals to, as we know, ks into kc. That means this thing is k. What does it mean? It's a wall factor. So you could now try to understand. You can find wall factor using this ks kc, as well as you can find the wall factor using a spring index. K is equals to 4c minus 1, 4c minus 4 plus 0.6115 by c. So this equation is also certified by ASME. Now k can be also found by 8pd by this one, but this is the theoretical way. But for practical way, you have to answer. You have to consider either this one or this one, because wall factor is one of the maximum factors that is calculated by number of calculations and number of trials and errors and experimentation. That's why it is reliable, as well as this is also reliable, because it is also a same things what they have done. By wall factor have done this one, and this has been done by the ASME, this American Society of Mechanical Engineers. Again, to consider, to understand, there is a twisting effect. That's why we bring this one. Theta is equals to mt L by jg. So j is the polar moment of inertia due to bar, and g is the modulus of rigidity. So from there we'll be putting the mt we know pd by 2, p into d by 2, the half of this one, that is d by 2, and I is pi dn. So sorry, it's L. There is pi dn. What is the length of the bar, the total length of the bar? This one consider. So how did it been considered? So let me tell you, the pi means the rotation. How much is the rotation? Pi into d. Pi is equal to 2 pi r. Okay, let me take this one. This rotation, this is a circle. So what will be 2 pi r? So what is 2 r is equals to d. Fine. So pi into d. How many turns are there? N number of turns. That's why it's n. Fine. So this will give me a complete length, as you can see over here. This will give the wear length also. It is also the wear length, because you are converting a circular point to a linear form. So rotational motion, rotational dimension to a linear dimension. After that, J is the polar moment of inertia of the bar. So what is the circular? That's why we know pi d4 by 32, and G is the modulus of rigidity. There's some values. Bar, because it's a cylindrical bar, that's why it's a pi d4 by 32. That is we have learned in a moment of inertia. So after that, this is where you can find a deflection. This will give you the deflection, and this will give you the stress, what stress it can create. This one, shear stress. Understood? What is fluctuating stress? Now, after giving a torsion shear of torsion stress over time, to respect to time, we calculate the fluctuating stress. This is the P mean, that is the stress of the mean by P max by P min, as you know. The P amplitude, what we can do, P max minus P mean by half. And what is tau m? Tau is the mean of the stress, shear stress. And so after that, we know what is Ks. Ks is 1 by 0.5 by C. So as well as where it comes in the Ks, you can see, yes, here from here we calculate. Here we will use this one, because fluctuating loading is a practical thing. That's why we are considering Ks and Kc. Fine. From therefore we can write Ta is equals to K 8 pi PAD by dq. So this is the experimental curve. What it gave, that we have this is a tau mean, and this is a tau amplitude, that is the stress mean and stress amplitude, where it has shown that three curves. That is a experimental curve which has gone in this way, that it has gone in a non-linear way, and line of failure is we have find out here, and design line is this one. We try to design in this line. Fine. So let me get this one clearing. Okay, so we try to design this one in this way, but we find the experiment line in this way, which makes a failure line inside. So that means our design may not be correct or may be correct. So as well as the load line is on this one. So load line, due to the intersection of load line, we get a failure lines like Soderberg curve. Thank you. Send your queries and everything. I'll for every questions and everything, and your get prepared for your exams, which will be UGC will give you all the details, and as well as your college. Have a nice day and stay home, stay safe.